Enlightened Designs, algae culturing systems. If anyone already knows lots about algae, you'll find this next bit very boring. I'll give you a very basic summary, but essentially we help people to grow algae in culturing systems. That places us in the environment and biotech sector, and we've had some fairly rapid progress, and we're looking to keep that momentum going, which is why I'm here. We're not actually looking for exact funds at the moment, but this is a kind of a heads up thing. So yeah, starting 2013, we're looking for investment. Algae, here's the science bit. They're microscopic plants. They invented photosynthesis. They also geoengineered the planet, turning it from a carbon dioxide-rich atmosphere into an oxygen-rich atmosphere. They're fantastically simple, but fantastically clever microorganisms. They use photosynthesis. There's no smokes and mirrors, there's no perpetual motion. They convert sunlight into chemical energy. They store that as sugars, lipids, proteins, so they're pretty useful. They use CO2 from the atmosphere. In the lab, we often use it from a tank because it's simple, but lots of people are looking at sequestration using CO2. Hang on, I had to say, oh yeah, no, I've done that, cool, good. They can be grown, the allure of algae is that they can be grown on unproductive land. For unproductive land, read the desert, basically. This is the long-term goal. And they can be grown in salt water. There's marine strains. These are the plankton that live naturally in the ocean. So there's no resource use for water, and essentially there's no shift from agriculture from food to fuel. So that's one of the great potentials. And they've got potential yields 10 times greater than any of the other fuel crops. So if we look, oh, and also they can be used for food. We can eat them directly. Some communities around the world already eat them and have done, and as biofuels. This is why everyone's interested. So you've got your soybeans down to palm oil. You know, we're trashing Indonesia to produce 6,000 litres per hectare per year. Microalgae have the potential to do over 10 times that. But a word of warning, there's a lot of hype around, and some people are offering you massive returns, which actually violate the conservation of energy law. They're quoting more production than the amount of sunlight falling on them. So there's great allure. What do we get out of them? Well, we always work on a value pyramid. So high value, but not much contained in the cells at the top. This is typically pharmaceuticals, nutraceuticals. So beta-carotene would be one, astaxanthin. Oh, this is a slightly older slide. Brilliant. Anyway, so we got, sorry. High value at the top, but not much in each cell. Less value, but more content. And then lower down, we're looking at biofuels, where it's a very low value product, but we need lots of it. So this is starting at the top. We can also use algae in anaerobic digester, co-use. It's good for wastewater treatment. They use nitrates and phosphates from the wastewater, so nutrient scrubbing. And the big one is third generation biofuels. That's for drop-in biofuels like biodiesel. Also, and there's a bit of controversy, carbon capture and storage. It's a no-brainer because they use CO2, but do they actually sequester it for the long term? The market, there's the reliable data from 2004. Your button's a bit close together. Yeah, okay. 2004, 9 billion. That's you know, that's not made up. That's published data. The potential market, obviously, for biofuels, we're into the trillions of dollars. That's what the interest is all about. It's particularly in the US. Exxon have put 500 million in. The Department of Energy is funding large projects, and the US military, strangely enough, is one of the biggest drivers of algal-derived biofuels. They want the big green fleet by 2020, I think. So how do we grow it? We need somewhere to grow it, and these are typically open and closed systems. So open, you get a large pond in in flat land, you have a paddle wheel arrangement to circulate it. They're very quick or quite cheap to build. Closed systems, you get a greenhouse, you put some pipes in, some large pumps, and you've got a growth vessel, both of which have problems. They're either subject to contamination and water loss or water gain, or they're very expensive to build and have limited scalability. Our approach, we've gone for the flat panel. So rather than open, we've gone for flat panel with a thin layer. This allows us to have much lighter mass systems, which means we can use lighter weight, so the cost comes down. We can use low-cost materials, typically from the packaging industry. So we use the materials and the techniques to make these systems. So this is our first one at Exeter University. It's the size of an A4 sheet of paper, small acorns, I think. The next one was 2011. This was at Plymouth Marine Labs, which we put together into a 5 square metre system. So because we've got less volume of water, these are typically a few millimetres of thick, we've got less water running through them, we need less pump power, so we can go net energy positive. It's highly scalable. We're still making these on a modular basis, so single units, but we're gearing up to roll production, which then you can do hundreds of metres in length, which helps you cover more land more cheaply. So yeah, here we see the small, medium, large, and this isn't the final version I sent, so you're not getting a rendering of. We're doing a version which is 4 times bigger than this, so we're scaling to 20 square metres next year. That's a Technology Strategy Board Smart Fund. And we're basically trying to do Moore's Law. Anyone in computing will know that you double the processing power every 2 years. We need to do it faster, so I renamed that as Moore's second law, or Morris's paradox. We've got to double it every year to get realistically large-scale production of biofuel in my lifetime. So we have to double every year, which means scalability, low cost. The markets, we're looking at the R&D sector. We've developed products and components which we can sell to existing members of the R&D community. That's in the short term. We could be selling certain sensors this time next year. There's also producers of high-value products on a fairly small scale. They're looking at indoor systems, so we could be selling to them sort of within 24 months. Volume production, so we're talking large areas or very large areas for wastewater, carbon capture and storage and biofuels. Realistically, I don't think 50 to 100 years, but we're certainly 10 to 20 years before you're covering significant areas. Everyone refers to the size of whales, but I don't know why they choose whales, but it always is. But that's the sort of level we're talking, and we're not going to get there with glass tubes and stainless steel. Why invest in Enlightened Designs? Well, we're an enabling technology. We're making things possible for the first time. We hope to be the first to market. We've got an IP portfolio, including patents. Our systems and components have been tested by academic partners. We're also publishing this year, which is a rarity for algae companies. We're configured for the algae market. We hope to be affordable and profitable by bringing down costs. We give customers the chance to provide a better or a greener product. And also, if you're in wastewater treatment, as soon as the EU nitrate directive kicks in, there's going to be fines out there for anyone with high amounts of nitrate in the water. So we could save you money. I'll just whip through. I'm the founder. We've got professional academics on the board. We've got seed investment this year to match our Smart Award. And we've got the IP side and business side covered. Lots of partners, academics, small businesses, government aid organisations. We're looking to fund further development of the business and the sales team. If we're getting into sales, we haven't got any sales team yet. We want to do further research by funding a CASE PhD studentship. I'm at 50%, I need to go full time. We need more technicians, a finance director. IP is expensive, very expensive. So we need that. And then, yes, commercialization at stages throughout the whole place. Oh, and some match funding. We need to do the next stage, which is development of prototype. That's the pre-commercialization stage. So we're looking to do that next year, and we'll be EIS accredited for any investment. Yeah, how do you get out? You could get out short-term, medium-term, long-term. If we're doing exponential growth, we'd hope to have exponential growth of the business. And in the long run, you know, realistically, when you're the size of Wales, you're talking about licensing agreements for major petrochemicals. I think I'll stop there.
Thank you very much. Right, who wants to start? Michael.
Yeah, I really like this. I think Algae is a great answer to the whole biodiesel, biofuels issue. And I think what's happened in biodiesel and biofuels is a lot of plants have failed because they've been caught between two big sectors that have no natural hedge. So you have the agricultural sector, and then you have the oil sector, and you're a little thing in between. The grain price goes up and the oil price goes down, and you're the one who's screwed in the middle. So I think if you can get away from the agricultural sector and feed into the biodiesel sector, you overcome that structural problem in the industry that has bedeviled a lot of projects so far. You didn't say how much you were looking for?
No, we don't know that. It depends what we're funding, but I mean, we're looking for there's short-term investment for short-term rewards, longer-term investment for larger rewards on the longer term.
Yeah, I mean, I think you'd fit very well with the university spin-offs people whose name I still can't think of, but it will come to me.
I've got it on a list to follow up, yeah.
And I think there's other, you know, it's very hard to get any investment sub $1 million. It's almost not worth the while. You've really got to be aiming the 1 to 5 million is a nice.
And 3 million and above is VC.
Yeah. VCTs would love this, I think. And I think you've got to look to double or treble their money within 5 years. And if you can have a business plan that does that, I can see you get a lot of interest in this, because I think it's further down the road than anything else we've seen today in some ways. And I absolutely see it. So I like it. Cool. Thank you.
Could I just say something? I see you seem to have your IP portfolio covered, which is good. Hurrah. But I'm going to sound like a broken record here. Have you thought about where you're protecting your IP? Is it only in Europe?
We've got a UK application which we then rolled out to PCT, which, as you know, gets more expensive. And we've basically cherry-picked the territories because, you know, I don't want to do 70 or 140 territories. It's the major algae players like Australia, the States, South Africa, I think we've done India.
China and Brazil I'd do as well.
Yeah, well, anyway, yeah, China. Tricky question.
Yeah, James, very interesting, very sophisticated, very technical. The thing that worries me about all this is just the scale of the phenomena involved. To build what is actually quite a sophisticated plant, you know, a thin film reactor the size of Wales, for example, is quite challenging. I think just
very challenging.
Not just in terms of finding a place which is flat enough and willing, but also just the physical implementation of such a thing.
Right.
The pipe work, the manifolds, the energy you're going to consume.
Definitely.
Managing the oxygen environment in the liquor and all that sort of scavenging the pollutants and. It's immensely difficult at that scale, I think.
Challenging. I mean, I think the challenges don't, well, they do scale to a degree, but if you can prove it on one scale, you can bring it to the next, and that's what we've done, you know, and we've proven we can grow it in 5 square metre things. We're getting nearly trebling of the biomass every day, which, you know, I think is a pretty good crop. Yeah. But yes, there's a lot of things to get right.
But, you know, yeah, all that stuff, that's physical stuff, that's all manageable one way or another. There will be an energy and a cost penalty of doing all that. And
no, most systems at the moment are net energy negative, so they use more to power the pumps than you ever get out of the product.
Yeah, so this is where I get to the scale of the phenomena issues. Then, if you look at the scale of the phenomena on the input, which is the budget for sunlight, you want to go places where it's nice and strong.
We're going to Huelva, which is Costa de la Luz in Spain, the coast
Yeah.
of light.
Yeah.
So they've got twice the sunlight that we have.
Yeah, so the people in Wales can sort of breathe easy.
This isn't really going to happen in the UK,
But
or
even
at
there,
scale.
you know, the figure I have in my mind is that if you look at an area like that, you're looking at installation of what, 250 watts per square metre, something like that.
Average 1,000, I think it gets up
okay.
to. Yeah.
It's, all right, but you know, flying the Atlantic every day, there are 1,300 jumbo jets going in each direction.
Yeah.
And when you fill them, it's 350 tons of fuel each.
I mean, and every car up the motorway, you know, we've got pumps going constantly.
Hang on, that is more than 500,000 tons of kerosene each way, every day, over the Atlantic only.
Yep.
Bear in mind after that, the aviation constitutes 2% of our energy demand.
Oh.
So, you know, I don't think this technology is going to get anywhere near meeting the fuel requirements of civilization.
I'm going to love to prove you wrong.
I hope you will.
Indeed.
But, you know, to me it just seems too difficult. I like the high-end products and all that sort of stuff.
Well, that's where we're going to start, and then, you know, I mean, I'm a realist. It's going to take decades to get there.
I don't think you'll ever get to this point where you start selling stuff at €1 a litre.
Right.
You'll be too busy selling it at €10 a litre. I don't think you'll ever escape from that position. You won't want to.
Well, happy days.
Can I ask you, it's an open pond system that you're working
No,
on?
sorry, we're definitely not open. We don't need flat land. We use flat panels. It looks a bit like double glazing. So it's two layers of one layer of clear plastic with the green goo, is the technical name for it, flowing up in between it. We circulate that. It looks a bit like a solar collector, solar thermal, or except for it's green. So it's a living organism. We harvest the algae as they treble every day.
And are you providing light to them yourself,
No,
or is
it's
it
solar.
only sunlight?
But you can do it indoors for the high value.
I've seen it done. I mean, I saw a Canadian company recently, which is working with the smokestacks, as they call it.
And you could do it indoors, but you're taking electricity, which is maybe 50% efficient production, 80% efficient transmission, 25% conversion efficiency in an LED lamp. You know, if you're doing anything other than very high value chemicals, you're wasting your money.
Well, they claimed, this Canadian company, to be it was the LED technology that was innovative.
LEDs are 24% efficient, so anyone who can get more than 24 cents out of a dollar.
I'll put you in touch with them. Maybe you could combine the two systems.
I'm a sun god. It's solar all the way. It's free.
Okay, well, now I just say there are lots of different options there, and I think the jury's out as far as Algae is concerned, because you know there's so many different ways of doing it, and as you say, it won't happen in the next year or two.
Yeah.
Thank you.
Well, I think that got a very positive response actually, and especially when there are kind of higher end value things to fall back on. You know, it seems a very fortunate position to be in. Now I think, so thank you. I think we have one more presentation. I don't know where it's